Okay, and we are re-recording. So welcome everybody. Thank you so much for joining us on this rainy Thursday to our September, I almost called it October. I'm so ready for fall. I'm like jumping outside a month for our September integrated pest management webinar. We are very fortunate to have Dr. Mengjun Hu here today to speak about strawberry diseases and their management. And I know that this is when a lot of strawberry plants are getting planted, and NeoP is one that's now popping up in everybody's planting. So I think this is super timely. Just a reminder, this webinar and all of our past webinars have been recorded and they are found on our YouTube channel. So you can go back and watch any of them. If you do not want your face recorded or your voice recorded, please keep yourself on mute and keep your camera off. We'd appreciate you doing both of those while our speaker is speaking, as well as to not distract people. So without further ado, we'll go ahead and hand it on over to our speaker.
Okay, very good. Thank you, Emily, for the kind introduction. Again, my name is Mengjun Hu. I'm a plant pathologist at the University of Maryland. So I responsible for small fruits that obviously includes strawberries. So very glad to have this opportunity and to talk about strawberry diseases and their management. So I'll start by saying that, the past season, 24-25, it was not great, especially for plasticulture strawberries. As we know, it started with an outbreak of Neopestalotiopsis, which is a relatively new disease at nursery level. As a result, plug quality was compromised, and some growers didn't really have enough plants. Also, those are also affected by this new disease. And weather conditions on top of that, it was fairly dry, actually too dry in the fall 2024 after planting. And, some growers are concerned about spreading the disease with overhead irrigation and, and combine that with a little bit with dry weather in the fall. That just made it worse. And also, since this is a relatively new disease and there is a whole lot to learn about it, and there is a lack of management options. So all in all, the strawberry season last year was a pretty short, and some growers had about 30 to 40% yield reduction, so which was unfortunate. Now, speaking of this new disease, and it's called Neopestalotiopsis, and we also refer to Neopest or simply as NeoP. It was first reported in Florida to 2017, and then where it had a major impact strawberry production in Florida and also in the following years as well. And ever since, it has been detected widely in the country and also in Canada, as well as Mexico. So it is widespread right now in North America. A little bit more background information. Now, this disease can infect the leaves. As you can see the picture on the right, oftentimes it resulted in a pretty prolonged lesion on the leaf. Under right conditions during especially like a wet extended moisture, it can progress rapidly and plants noticeable decline in days after planting. Now, the optimal temperature for the pathogen is somewhere between 75 to 86 Fahrenheit, and it's considered a warm pathogen, just like anthracnose. And with the infection, sometimes it results in black pycnidia. Those are tiny black bumps on the towards the center of the lesions, and this actually can be confused with more traditional diseases like leaf blight, leaf scorch, and some of those the traditional diseases caused by different pathogens. And in this region, I wanted to point out that it's very common to have leaf symptoms as shown on this picture. But again, it can also cause crown issues and resulted in plant decline, stunting, and that's what actually many growers experienced during fall after planting. However, regarding fruit infection by this pathogen, it was rarely observed in this region, which is different from Florida. So just wanted to point out that. Now, the local impact of Neopest this past season, particularly with plasticulture strawberries. As I mentioned, during there was an outbreak of the disease at nursery level, and during fall 2024, the samples, we had samples from 6 different farms in Maryland in the state and found detected the presence of the pathogen on 4 out of the 6 samples that we received. The cultivars that confirmed with the infection include Ruby June, Florida Brilliance, Chandler, San Andrew, as well as Merced. So some of those are, California cultivars. And so when we have samples, we typically start with surface sterilization in case you were wondering about the process. And we surface sterilize them and then isolate the infected area for culturing on artificial media. And for Neopestalotiopsis, actually, it's pretty easy to identify and with the spore morphology. And if we had some doubts or questions regarding the identification confirmation, we extracted DNA and did a molecular identification with PCR and Sanger sequencing. So, okay, move on to disease cycle of this important disease, Neopest. And unfortunately, nursery transplants are considered the primary source of inoculum. Both plugs and the deep tips can be infected by this pathogen at nursery level. And sometimes, the pathogen can stay latent, the disease can stay latent. So even though the plants may look perfectly fine, but they might start to show symptoms soon after they've been planted in growers' field. Under right conditions, like a rainfall, overhead irrigation, things like that, and then, the disease will progress and produce the spores from those lesions and continue to infect healthy plants. And during fruiting, if there is a high disease pressure, and oftentimes it could also result in fruit infection by this pathogen. Again, in this region, fruit infection was not really observed, was rarely observed. The most common symptom that we have is the leaf spots, leaf lesion, as well as plant decline, crown infection due to this pathogen. And those are, the damage was pretty much done during fall season after planting. A little bit more on disease symptoms. As I mentioned, the leaf symptoms are very common, and it can be, the lesion can be pretty big, pronounced, with those small black pycnidia bumps on the center, towards the center of the lesions. And then stunted plant growth, that's also pretty common during fall season before the plant go dormancy. And with the plant, stunted plants and plant decline, oftentimes that indicates there's something wrong with the crown. If you were to cut the crowns open, and you would see some dark lesions in the crown, just like anthracnose crown rot, right? So during fruiting, you can also expect to see some reddening of leaves, stunted growth, and obviously that would result in less fruit production and a short season as well. Okay, cultivar susceptibility. I think many of us are very interested in cultivar susceptibility, and it's actually interesting that the cultivars do seem to have differential susceptibility to this disease. And this was a study done in Indiana. This was done in greenhouse, under greenhouse condition, and where they evaluated the foliage symptoms of many different cultivars. And they found that some cultivars are highly susceptible, where you can say those bars are pretty high. The y-axis, that's the disease severity, right? And up to 35, close to 40% disease severity. Whereas some cultivars on the right hand had a very little disease severity, including Galeta, Merwena, Flavorfest. So there appears to be a good range of disease susceptibility, which is good news. But I also wanted to point out that this was evaluated based on foliage symptoms. And as I mentioned earlier, that the disease can cause the pathogen can infect the foliage, the leaves, but also can infect the crown, right? So the leaf symptoms, foliage symptoms are not as bad as crown infection, right? The crown infection would result in plant death, plant decline, whereas the leaf symptoms, leaf diseases are somewhat tolerant. I mean, it's you not as damaging as those crown infection. So anyway, and I do believe that there is more to learn about regarding the correlation between foliage symptoms and the crown infection. And this figure probably would give you better ideas about such, possible inconsistent correlation, I would say. But again, we need to learn more about it. And this figures that was recently done by North Carolina State University, where they also evaluated cultivar susceptibility with different cultivars. And the figure above, that's a plant yield. And Frontera, that certainly is a winner out of those cultivars, followed by Camarosa. And both from Fronteras and Camarosa had a good yield, and also this one Rocco. Yeah, I mean, and then you have some other cultivars are in the middle, and some cultivars are really like Albion, right? Really did a bad had a bad yield, plant yield. But when you look at the figure at the bottom where it shows the average severity rating, now I wanted to point out that where you say the Camarosa and the Frontera that are in the middle. If you look at just the figure at the bottom, the average severity is like somewhere between 40 to 60%. You would think it's a lot, right? But then when you look at yield, that tells you sort of a different story. I think, I mean, we do need to, like I said, better understand how the impact of this disease infection on yield production. If let's say cultivar may have some differential susceptibility, different tissues may have of the same cultivar may have some differential sensitivity to this disease. Again, that's something we need to understand more about it. So moving on to pathogen management strategies. Now, growing strawberry is a high risk job, I think, and do not plant unhealthy appearing transplants to start. I think that's something that we should we should do. Try not to plant unhealthy appearing plant transplants. That's just very, very risky. And then avoid planting highly susceptible cultivars. And some cultivars tend to be more susceptible, including Florida brillians, Camino Real, and Albion Rubijun. So those ones are susceptible in terms of disease rating as well as yield reduction, yield fruit production, right? And use less susceptible cultivars. Some cultivars tend to have a less susceptibility to this disease, again, which is good. But like I said, the foliage symptom may be very common across the cultivars, and we need to better understand what does that really mean, right? So if if certain cultivars have a better tolerance to crown infection, I mean, it would be okay even though have some symptoms on the leaves. Now, good sanitation practices in the field is also important, and the field rotation if possible. So chemicals. Now, there was a study done by University of Florida where they evaluated the efficacy of many different fungicides for Neopestalotiopsis control, and they found that the most effective materials, including Cyran and Mirror's Prime and Switch. I mean, obviously, Mirror's Prime and Switch have the same active ingredient, right? That's active ingredient does the job. I mean, the fluorodeoxyonil. And the NC State spray program also recommends Cyran and Switch, but also includes Tilt and the Rime, and largely consistent. There was a research in Mexico that showed the pre-planting dip significantly improve the survivability of transplants that are latently infected with this disease. Switch has a label for pre-plant dip and has proven efficacy for anthracnose. Now, Now, when comes to fungus application, certainly the coverage is important, and need to be applied with enough pressure to penetrate the canopy. So, to summarize the management strategies, to start, consider tolerant, less susceptible cultivars. That would be less risk, right? Less risky. And do not plant unhealthy looking plants. And considering utilizing a plant pre-plant dipping, especially when you grow in susceptible cultivars, and try limit work in the field when plants are wet. Again, the disease is dispersed by water splash, rain splashing. So if plants are wet and while doing some work in the field, that would increase the chance of spreading the disease within the field. So that's all I have for the new disease NeoP, and I'm going to move on to a different disease, strawberry anthracnose. And this can be also it is a major fungal disease on strawberries. And this disease is caused by species within Caltotrichum genus, specifically Caltotrichum agitatum and Caltotrichum gallodiospreadis. And those are two species complexes, and species within those two complexes have been found to be responsible for strawberry anthracnose. And similar to Neopestalotiopsis, it's also considered a warm pathogen, and the infection typically is favored by extended moisture and warm conditions between 70 to 85 Fahrenheit. Symptoms normally referred to as a black spot on the upper parts of the plant, as you can see on the picture to the right. And bright orange sporulation typically occur on the mature fruit as well. And the roots and the crowns can also be infected by the pathogen, by Caltotrichum species, just like Neopestalotiopsis. So there are some more pictures about the symptoms of strawberry anthracnose. With a fruit infection, again, it would result in sunken lesion, where you can see some seeds are blackened, and under right conditions, you may also see some orange sporulation towards the center of the lesion, and the pathogen can also infect even the green fruit under the right condition, but that's pretty rare. On the petals, flowers, and those can all be infected by the pathogen. So where does it come from and how does it spread, right? With Caltotrichum, keep in mind that that's a rain splash pathogen, so it's dispersed through rain splashing, similar to Neopestalotiopsis. With on low growing crops like on the ground, right, like strawberries, the chlamydia are typically spread over short distance. They don't really travel for long distance unless there is a sort of a hurricane, right, that can bring over to for a long distance. Possible source of infection, again, nursery transplants are considered the major source of inoculum. And soon after planting in the fruiting growers field, the chlamydia can be produced and continue to infect the healthy tissues. So in addition, a possible source of infection, weeds. Weeds can also, there have been some studies that indicate weeds could be a reservoir for this pathogen. The fungi, though, seem to live on weeds as an endophyte. However, if there was another study that showed with herbicide application, certain herbicides may stimulate the release, may help with the release of the spores from weeds, and that could serve as an inoculant of strawberry anthracnose. And survivals in the soil, it's not a typical soil-borne pathogen. Neopestalotiopsis is also not a soil-borne pathogen, but they both can survive in the soil. With Caltotrichum, it can survive up to 12 months under dry conditions. But the survival declined rapidly under moisture conditions, and there was a study that showed at 11% soil moisture, so 95% loss of viability can be expected after 70 to 75 days. But in soil at a field capacity, 22% moisture, then a 95% reduction in population was recorded just within a couple of days. So the water content, moisture content tend to play a major role on the survivability of the pathogen in the soil. So this picture shows the life cycle of the disease cycle of this anthracnose disease cycle. Again, nursery transplants are considered the primary source of infection, and then under right conditions, the symptoms start to show up and produce Colidia spores that continue to infect healthy tissues, and continues, right? And so I mentioned earlier that there are multiple species involved that can cause strawberry anthracnose. A few years ago, we did a study to try to understand, characterize, identify species that we have in this region. We got samples from Maryland, Pennsylvania, Virginia, and North Carolina. You can see that out of 1,200 isolates we collected, most of them actually were found to be Cold-Tortricum lymphae, especially on the fruit. 95% of the infection was caused by Cold-Tortricum lymphae. And both lymphae and the Cold-Tortricum fiorinae, they're under agglutinin complex. And the sialency, we found the sialency only from the crown tissue, and that was under Gloiosporides complex, right? So anyway, so those are the scholarly morphology of different Cold-Tortricum species that we isolated from strawberry samples. Now, with this table, I just include those fungicides currently labeled for strawberry anthracnose control. Although there are different chemical classes fungicides labeled, many of them have resistance issues. Especially FRAC 11, that's strobilurins, that typically is considered the go-to fungicide for anthracnose. Unfortunately, there is a high risk for resistance. The switch right here, Amiros Prime, and those ones are still effective against anthracnose based on our understanding. And multi-site fungicides, Thyron and Captan at the bottom, those ones have a much less risk for resistance development, although their efficacy may not be as good as some of the single-site fungicides if resistance is not a concern. I also wanted to point out that because there are different species involved, cyphenomethyl, FRAC 1, is ineffective against agglutinin complex, whereas fluorodeoxyonium, that's active ingredient in both switch and Amiros prime, may be a little bit weak for species within Gloiosporides complex. So we've also determined frequency of resistance to FRAC 11 to strobilurins. And you can say that the resistance to strobilurins, FRAC 11 fungicides, is pretty widespread in our region. So, okay, moving on to strawberry gray mold. This is also my favorite pathogen, and usually cause fruit rot, right? I mean, but sometimes, occasionally, you can see some crown rot infection caused by botrytis, especially during early spring when you remove the row covers, and you might find a few plants that had some botrytis at the crown area. Unlike, it's different from anthracnose and Neopestalotiopsis. This one is mainly dispersed by wind. It is an airborne pathogen, right? But obviously, splashing water can also help with the dispersal of the pathogen. Now, it's also favored by wet and cool conditions, not like anthracnose, right? The optimal temperature for this pathogen is between 60 to 75 Fahrenheit. It's a cool, damp disease, and unfortunately, the disease relies heavily on chemical control. And there are a number of chemical classes of fungicides currently labeled for botrytis management. Now, botrytis cinerea is actually considered a high-risk pathogen for resistance development. Now, indeed, resistance has been detected to almost all those chemical classes of fungicides, single-site fungicides. Multi-site fungicides, Thyran, Captan, they have some efficacy and they do not have resistance issues, which are good. Now, disease cycle, life cycle, the transplants can be a source of infection, but keep in mind that it's probably not the primary source of infection because this pathogen is airborne, right? Which means they can travel for long distance and can also come from your nearby infected crops. And then the infection can happen multiple times during the season and cause significant yield reduction. So, okay, cultural controls. Now, for culture strawberries, there are not many options, but if you have resources, you have time, and I mean, you can try to remove dead leaves in the spring. That could be a sort of source of inoculum for botrytis. For matted rose strawberries, keep rows narrow and control weight to the extent possible. And importantly, harvest thoroughly, keep up with harvesting and remove a rotting fruit as much as you can. And anything really that helps keep a foliage dry would be beneficial to the disease management. Again, this disease is favored by extended moisture, cool condition, right? So anything you can do to dry the canopy, dry the fruit faster, that would certainly be of help. So with this table, I summarized the chemicals, fungicides, along with their efficacy, as well as resistance frequency for botrytis control. And you can say, again, there are a number of chemical classes of fungicide labeled for gray mold. Many of them had resistance issues. Some of them are really, had high, the resistance frequency are very high or median. And two fungicide, Thyran and Captan, those ones, although efficacy are not good as good as some of the single-site fungicide, but they're unlikely to develop resistance. Okay, moving on. Now, years ago, we've done a study to detect determine the frequency of resistant in botrytis to all the chemical classes of fungicide that are available for botrytis control. And we did that for 6, 7 years. And you can say the siphon method, that's a FRAC1 Topsin M. It started with a very high frequency of resistance. And I don't think, this one has been really used for botrytis control. Perhaps drawing that's actively grading in pristine and started with about around 20% of resistant frequency, but over the years increased to almost 70-75%. And fenhexamide that's elevate, active ingredient in elevate. Boscalate, that's another active ingredient in pristine. Cyprodiol, that's one active ingredient in switch. And iprodion or eprodion, that's active ingredient of Rovera. And the Fludix oil, that's the other active ingredient in switch. And then the sensitive isolates basically mean that the isolates are sensitive to everything. So you can say that overall, there is an increased frequency of resistance over the years. And the Fludix oil, that's an ingredient again in switch, as well as Miravo's prime, and some of the FRAC7 SDHI material that are, have relatively speaking less resistant frequencies, less resistance issues compared to the others. So moving on to Phytophthora crown rot. Phytophthora crown rot can also is also pretty common in our region, and there are different Phytophthora species involved. The most common one is the Phytophthora cactorum. And believe it or not, nursery stock can also be a source of infection, but also, I mean, this pathogen is a waterborne pathogen, okay? Waterborne pathogen, which means it can also come from your irrigation water. And management, cultivar resistance, some cultivars are highly susceptible, like sweet Charlie. Fungicides, some fungicides are registered for Phytophthora fumigation, might also be of help. And soil drainage is a waterborne issue, so good soil drainage will be helpful for Phytophthora crown rot. Now, just want to mention that in the past few years, we have frequently, not frequently, but sometimes got samples of flavor-fast strawberries with some, decline, stunting symptoms, and about half of those plants actually were diagnosed with Phytophthora, but maybe something else going on. But flavor fest seems to be affected pretty often with this kind of issue. So the particular specific symptoms including collapsing plants and red-brown or crown tissue. So fungicides, in terms of fungicides, as I mentioned, there are different fungicides labeled for Phytophthora, including FRAC 4, which includes red gold and Metastar. And then this fungicide, this group should be through drip application only during fall and early spring. Resistance is a concern though, and it was found pretty widespread in the southeast. As far as I know, there has not been report of FRAC 4 resistance in our region. And the phosphites, such as that's a FRAC PO7, such as Prophyte and Phostrol, as well as Adiate, and those can also be useful through pre-plant deep as well as foliar application if the symptom persistent. I mean, the foliar application could also be useful. However, they're not as effective as a FAC4. They do have a lower risk for resistance development. There is a relatively new product called Arundis Gold, which is a combination of FRAC4 and the FRAC 40 line. And trials done that indicate similar efficacy as a FRAC4 fungicide alone. But I guess if there is a resistance concern with the FRAC4, then Arundis Gold would be a better option. FRAC 11 azoxastrobin, and it's labeled for leather rot only, not the crown rot. Resistance has been recently reported in Florida. Now moving on to black root rot complex, and this issue is more common with matted rose strawberries, and it involves various fungi and stresses, right? Specifically, Rhizoctonia, Pethine, and Fusarium. Those are the common fungal species associated with this issue. And niching nematodes can be also a factor, and heavy compacted soils, some abiotic stress like winter injury, drainage not good, and drought, or even herbicide injury could promote the development of this disease. And this is a picture of black root rot, where you can see the roots are become black and rotten. Okay, and control measures. There's some things that you can do to help with the black rot and to kind of minimize the risk of black root rot development, including site selection. You want a good drainage, rotating out of strawberries, and cover crops. Things that you can do to increase soil organic matter content. And before you planting strawberries, you may also want to consider a nematode test to ensure that it's good for it's good. Okay, so last disease I have is powdery mildew. Powdery mildew is also pretty common, especially in spring and the fall with matted rose strawberries. And the cultivars, including Flavorfest, Galeta, Early Glow, and some of those are, popular cultivars for matted rose strawberries. And those ones are very susceptible to powdery mildew, unfortunately. And the disease, it's very easy to control if we can spot it early. But the problem is that it's really hard to detect at the early stage. Once symptoms occur, it becomes pretty hard to control the disease. Now, fungicides may only be needed in the fall and the spring if the disease is a concern. So this table summarized different chemicals, active ingredients, along with their efficacy and the resistance risk for powdery mildew. Likewise, I mean, there are different chemical classes, fungicides labeled for this disease, but some of them have resistance issues. So now this is my last slide. I just wanted to give a few bullet points regarding resistant management strategies. Now, first, the best fungicides are not as good as good weather conditions, right? And the fungicide resistance is something that we spray more, we would get more resistance issues. So we wanted to minimize unnecessary sprays of materials that have a high risk for resistance development. In other words, we spray as needed, okay? And then primarily use multi-site fungicides, which do not tend to have resistance issues. And when the disease pressure is high, then consider tank mixed with a low risk fungicide at a higher dose and with a higher risk fungicide at a lower dose, right? And because more high risk fungicides are involved, then the more the resistance selection pressure would be higher. And then we wanted to limit each frag coat, and this applies to single site fungicides only, to 2 applications per season. With that, I'd be happy to take any questions, and good luck in the upcoming season. So.
Thank you very much for talking with us today. Do we have any questions about strawberry diseases or strawberries in general?
Hello, this is Mary Olson. I have a question. Can you hear me?
Yes.
Okay. The first 2 diseases that you spoke about sounded as if they looked fairly similar on the
Correct.
plants. Is that, yeah. Is there something that can distinguish one from the other?
Yes, with NeoP, the new disease, oftentimes you would expect to see some more pronounced uh, leaf spots, leaching on the leaf, whereas anthracnose doesn't tend to cause much infections on the foliage, on the leaves.
Uh-huh.
And with NeoP again, you would expect to see some leaching, some spots on the leaves, and also with the fruit infection. Again, we don't really see much fruit infection with NeoP in our region, but if it occurs on the fruit, then it's a little bit slightly different from anthracnose, which tend to kind of make the seeds blackened. With anthracnose, you would expect to see some sunken lesion with blackened seeds. But whereas, the NeoP, we don't oftentimes see the blackened seeds.
Okay, thank you.
Yeah, sure, you're welcome.
Well, while I have you, how about, are there 1 or 2 sprays that are good at combating multiple strawberry diseases at the same time?
Multiple disease, yes. I'll start with the multi-site fungicides. I think multi-site fungicides, I forgot to mention that should be a sort of a backbone of our spray program, right? Because those ones they have a much lower risk for resistance development, and they also have a pretty broad spectrum of activity against some major diseases. For instance, thiron is is one of the best for NeoP, the new disease, and also has a pretty good efficacy for botrytis, and also has a moderate efficacy towards against anthracnose. So thiron and captan also similar. Captan efficacy is better for anthracnose, and moderate for botrytis, and also can be also helpful for NeoP to a lesser extent. Those are multi-site fungicides we typically use. And then single-site fungicides, those ones have high risk for resistance development. Switch, and that with active ingredient of fluorodeoxyonil, that one has been is very effective against anthracnose, Pathologist species, and it's also one of the best for NeoP, Neopestalotiopsis, and also very good efficacy for botrytis. So it looks like Switch is a winner. But again, it's a single-site fungicide, so the potential resistance is a concern for sure. Okay.
Thank you.
Yeah, sure.
Thank you very much. Do we have any other questions?
I have a question.
Sure.
Yes.
For those that are growing organically, is there any way to control or minimize these diseases without spraying any of these chemicals?
Well, I want to start by saying that it's very challenging to grow strawberries organically in this region. I mean, because our weather conditions are typically favorable for a variety of fungal pathogens like botrytis, Pathologist, and so on. So I would say if you want to try organic strawberries, you certainly want to start with clean plants, right? The plugs, transplants, planting materials. If you're considering plastic culture, and have to be clean, right? And then perhaps more like sanitation practices. Once you see some infected berries, plants here and there, you would need to remove them immediately. So more input, labor input, more sanitation, things like that in the field that might be feasible in drier years, but during wet years, I doubt it. I don't think it will be really helpful. I'm not sure if
Would,
that question. Yeah.
oh, I was just going to ask, would it be better to plant in a high tunnel setting so they don't get overhead irrigation and just stick to drip? Would that help at all as
Yeah,
well?
absolutely. I think those fungal pathogens are favored by wet conditions. Anything what we can do to keep the water of the plants would certainly be of benefit. Yeah, thanks, Hayden. I think tunnels, high tunnel, low tunnels. I mean, those things are pretty labor intensive, right? And really requires more management efforts. So something to think about.
Any more questions?